This is a super key problem and is a big part in our belief of why the robotics industry sucks so hard.
We all know robotics is hard. One reason it's hard is because it's hard to find off-the-shelf components you can build a business on. Because of this, most robotics companies end up reinventing the wheel. For example, building their own mobility stack. And this is a bummer because it's a huge barrier to entry for robotics startups. Specifically, you may have to raise millions of dollars and work for a few years to solve undifferentiating problems, like autonomous navigation, before you can even start on your startup's core problem. This is why what Polymath Robotics is doing is exciting. They're creating a platform that solves robot navigation for a large number of industrial use cases, so you can just build on top of it and not reinvent the wheel. They're also doing a better job than you probably would because it's their core problem, and you might cut corners because of deadlines. I really like where this is going and expect more companies to follow Polymath Robotics' lead and make services for hard but undifferentiating robotics problems so you can use them off the shelf. I think this is a great thing for the robotics community as it makes robotics startups a little bit or even a lot easier. And that makes it so that we're more likely to see robots doing dull, dirty, and dangerous tasks no one wants to do sooner. This was a tremendously fun interview for me. I think you're going to like it too, especially if you're interested in or curious about robotics opportunities for mobile robots in industrial spaces, if you're curious about new and potentially powerful business models for robotics companies, or if you're a hardcore nerd and love safety certifications and requirements testing. I know some of you are out there. You're going to love it. Check out the episode description for timestamps if you cannot wait. Lastly, if you enjoyed this conversation and want to hear more from Stefan and Ilia, they have a podcast called Automate It, which is available on all the podcasting platforms you'd expect. It's a lot of fun, and I recommend you check it out. After you watch the interview, I'd love to hear what you think. Do you think the approach Polymath is taking is good for the robotics community? Do you imagine more robotics companies doing something similar? I'd love to hear what you think in the comments or on X. Without further ado, here's our interview. Hi, everyone. Stefan, would you introduce yourself?
Yeah, of course. My name is Stefan Seltz-Axmacher, and I'm CEO and co-founder of Polymath Robotics. At Polymath, we're making it really easy to add autonomy to any off-highway vehicle. And before this, I worked on self-driving trucks at Starsky, where we put the first driver-out truck on a public highway.
Mm-hmm. And Ilia, would you introduce yourself?
I am Ilia Baranov, co-founder and CTO here at Polymath. Before this grand adventure with Stefan, I was working at Amazon on their home robot Astro and have lots of fun stories to talk about there. And then prior to that was at Polymath Robotics, was one of the early folks there, developing a bunch of the research and industrial autonomy.
Mm-hmm. Now, Stefan, would you tell me about Polymath?
At Polymath, we're building a modular stack where we're doing everything from sensor drivers all the way through throttle and steering commands for the software that runs onboard a vehicle to make it move from one point in space to another. So we're not building hardware, we're not building apps to tell robots what to do, but kind of the really, really difficult but undifferentiated software packages that make a robot move through space. We've productized that, and we have it on more robots than we have people on our team.
That's so cool. How many people on your team and how many robots do you have it on?
10, and I think 11 robots going on 13 or 14.
That's exciting. Hell yeah.
Yeah. And they're all different types of robots too. It's not the same thing 10 times. We're on things as varied as like bulldozers and tractors, articulated dump trucks, and all sorts of stuff.
That's so cool. And so you mentioned you're not doing hardware. How are you interfacing with these different vehicles?
Yeah, so one of the things we had talked about with Stefan early on is that we had thought kind of robotics keeps reinventing the wheel. And Ross's conception or the robot operating system was that we want to reduce the amount of reinventing the wheel by having a common set of communication packages and examples and community. And that helps a lot. But we had seen that a lot of people will build this kind of vertical stack for their particular robot or particular application. And we just decided that we want to abstract that away. So we have we call it a hardware abstraction layer, pretty standard term, for input sensors. And then we have the same hardware abstraction layer for the output to the vehicle. And that output to the vehicle hardware abstraction layer takes care of things like what is the kinematic model, turn radius, maximum speed, what does the footprint look like? And so the core piece between those two hardware abstraction layers doesn't really change because all the complexities that's unique per vehicle are captured by those two layers.
Very cool. So you have a good way of talking to... Oh, go ahead, Stefan.
Yeah, because the problem that we're solving is if you were to leave your day job to go start, say, an autonomous tractor, the vast majority of the code you'd write in the first 2 to 4 years would be fundamentally undifferentiated from any of the other 150 or so autonomous tractor companies. You'd just be like working really hard on a really hard set of problems that no one cares about for you if you solve them successfully.
Yeah, for sure.
What we're doing is we're giving you that as a product so you can focus on integrating it into an actual product that some farmer somewhere or some mine operator somewhere or some whoever cares about. And you can focus on actually just making robots valuable as opposed to being the 1500th team to reinvent point-to-point navigation.
So are you thinking of it like you have this software that handles mobility for robots, and you are selling it to businesses that make like tractors or big vehicles, and so then they outfit their vehicles with your software, and they're selling that complete package. So you're selling them the autonomy that they use as a service on their hardware, in a sense.
So we might sell it to an OEM like you're describing. We might sell it to some big industrial company who's really sophisticated and can write their own software to tell robots what to do. Yeah.
I love it. So how does it, I guess, Ilia, how does it work in terms of, like, are you connecting over the CAN bus with the vehicles, or how are you actually interfacing with the, what do we call it? The vehicle? Whatever it is?
The vehicle, the robot, we have this discussion back and forth. Like, is it a vehicle? Is it a robot? Is it machinery? Is it like industrial equipment? That's a marketing problem. Luckily, I don't have to deal with that too much.
Yeah.
Yeah. So yeah, as part of the interface layer, one interface we have is socket CAN, which can then talk to a whole bunch of CAN-based equipment. But the most extreme case we have is actually one of our hardware partners called Hardline in Canada. They're now part of Hexagon. They have a 1996 bulldozer, which is entirely mechanical and hydraulic. And so the only interface we get to it is open this valve or close this valve. That's the most control we get to it. And so in that case, our hardware abstraction layer is abstracting away all the valve controls up to a level where it's, okay, we do positional loop closure using all the sensors we have, and then we control this thing like an unknown plant that we throw valve controls at and get speed out of it.
So you are doing, I thought you were not doing any hardware, but you are doing hardware for custom solutions like this.
So we don't.
No,
so we don't.
Even in that case,
they're doing it.
Yeah.
Okay.
So like an interesting thing, and I think everyone who's done robotics has seen, like, when you try to build the vehicle or when you try to retrofit the vehicle, there's an incredible amount of really hard custom one-off work to retrofit this 1997 bulldozer or this 2023 tractor or this whatever. And that work is really hard to do when you're a 5-person team and the same people doing that mechatronic design are also writing the code, are also building the ML algorithms, are also building the app, are also figuring out how to operate tractors as a service. So there are, however, a whole bunch of teams all over the world, including Hardline up in Canada, who are just mechatronics consulting shops where they can show up, look at a vehicle. They have a pre-fit retrofit kit. We'll customize it for that specific vehicle. And then we can talk to their API and issue commands to it.
That's super cool.
So we get to just be a software company and not go be in cold places to bring up robots.
So hopefully I'm not overstating our position here, but the equivalency I like to draw is that you can think of us as Microsoft in some sense, and there's a whole bunch of laptop manufacturers in the world, and like an Asus laptop and a Dell laptop are fundamentally different beasts, but they comply to some underlying hardware abstraction layer standard that then our OS can just sit on top of and control. It's stretching the analogy a little bit too far, but that's the direction we're going, where there's these retrofit and service and OEM companies all over the planet, very specialized in their particular vehicles. And all of them know how to treat their particular vehicle. And all they have to do is give us some level of computer
You just
control
need the
over it.
interface. Yeah. And are you doing it all with onboard sensors for these? I suppose you
Yes,
probably. So how would you I suppose, is it all GPS driven?
it can
I'm
be.
trying to
It
imagine.
can be.
Yeah, so
Yeah.
your approach is quite modular, depending on the needs of it, is what it sounds like.
Yep.
Okay.
Because sometimes
Ah,
GPS solves all your problems and sometimes it doesn't exist.
yeah. And then, yeah, and sometimes it doesn't exist. And sometimes you have crazy reflections if you're using RTK and all sorts of things. Okay. So you have this modular layer. The software you can run on a whole bunch of different hardware. I like that approach. What exactly, being that you're modular, I suppose there's a bunch of things that you have the ability to do, but what are
Yeah.
kind of the core competencies of the, I don't know, what do we call your software? Like, how do we refer to it?
I don't know, again, if this is a marketing problem. We just call it the autonomy core, the kind of
Okay, the
centerpiece,
autonomy core. I just call it
right?
the
And then
core.
the layers around it, or the core.
Yeah.
And yeah, maybe that's a good movie too. Anyway, um, there's the hardware abstraction layers around it, but the core is the piece that we really put a lot of effort into, and we try to change as little as possible.
So what
So think of that as
functionality is in your
everything.
core? Oh,
Uh,
go ahead,
so
Stefan.
so think of the functionality of that as everything from literally running the drivers on whichever sensors we happen to have to make sure that we're getting data from the lidar, we're getting data from the RTK GPS, we're getting data from the radar, or whatever combination of things we happen to have, turning those into some preset things like point clouds, turning that into
Common data
cost
types that you
maps.
can use on a
Yep,
lot of things. Uh-huh.
and use over and over
Exactly.
and over
A lot of
again,
the a
and
lot of the
then do
input hardware abstraction layer is basically turning into common data types and having
Yes.
as few of those as possible that are as widely defined as possible.
Makes sense. That's probably the best way to scale, is what I would
I mean,
imagine for this.
basically our secret evil plan, and honestly it's part of our sales strategy as well, is we tend to just talk to our customers about how we've built things, and it tends to be how they wish they could have gotten to build things if they didn't have a 6-month deadline when they were first building their whatever. And because the reality was when they thought they were going to start whatever autonomy project they're currently on, they thought, this time I'm going to do
It'd
it
be
right, it's going
easy.
to be reusable.
Oh,
And then some jerkwad CEO changes the deadline, or
says
some
the CEO.
customer
Yeah.
says I want some additional feature or whatever, and the engineering team cranks out a bunch of garbage spaghetti code in the last 3 weeks that then kind of sort of works for the rest of the robot's life. Like, everyone wants to build robots this way. We've kind of been free of the original sin of being tied to a specific use case that's enabled us to build a highly reusable, adaptable, modular autonomy code.
Yeah. So that sounds awesome to me. And you guys are using the robot operating system pretty heavily
Mhm.
with this. So
Yeah.
the way that I'm sort of thinking of this now is it's kind of like it's an additional abstraction on top of ROS that manages a lot of things.
Bingo.
Almost. Okay. Could you almost say it's like a behavioral level where you say I want it to do these
So
things, or how, or is it
yeah,
just
so behavior
unifying a lot of
control
things, or maybe it's both?
behavior control is a lot of what we do. So we
Yeah.
do have a behavior tree and a behavior engine, especially an API layer to command our vehicle and how that all interacts. But yeah, I mean, I get that a lot from Roboticist, where people say, well, what you're describing is basically ROS, which, like,
Well,
absolutely,
higher
huge fans
level,
of ROS
easier
2.
to input
Right.
stuff and get it to do what you want.
And again, yeah, and I think
Probably
the
does
comparison
resource
I give
management
is
and all sorts of things.
exactly. And the comparison I kind of give is ROS 2 is an excellent open source toolbox, and we're providing just the whole house. And like, yes, you could use the toolbox and build the house, or you could just go to us and we'll build you the house, or we have a house that we can just copy paste.
Do you guys know
Um,
in web development, there's like Ruby on Rails or something like this, which streamlines a lot of things? Would that be a
Yeah.
fair comparison? Ruby on Rails, but for robotics in some sense, or is it
I
not
think
quite
so.
broad enough? And
I'd
Ruby on
say
Rails, but for mobile robots, I suppose, or
for mobile robots, I'd say it's even one layer above that. I would
wow.
say
So
yeah.
our API, like, we have a relatively straightforward REST API where, like, commands might be go to this GPS coordinate with this heading. and then we just do that. So like we have a customer, for example, who's a big conglomerate. They have an in-house built ERP, written by
What's an
someone
ERP?
as an enterprise resource program. So basically, it's a software program that runs their operation, their multi-billion-dollar
see.
operation. It's been written by this guy, like literally a guy, over the last 20 years as
Oh my
I
gosh.
think a monolith in C#.
That's horrible.
He can issue commands to our robots. Even though he doesn't know much about geospatial data, he knows nothing about safety engineering, he knows nothing about machine learning. He can issue commands to robots that we drive in their fleet. So that, for example, the first time we were doing an integration test, he was like, I'm sending messages and you guys aren't moving. You've been making all these promises about your robots working and what's going on. And we looked at the message, and the GPS coordinate he was sending us to was 0,0, which, for those of you not familiar with GPS, is the middle of the Atlantic Ocean. We can enable our customers to just send simple commands. Even if they're unsafe, we won't do unsafe things. Like we won't leave the geofence in that use case. If you try to order us to drive into an obstacle, we won't, unless you for some reason configured us to do that.
I heard
So
on
now
your podcast
regular
that someone tried
software
to do
engineer-
that, and your
Yeah.
geofence saved something. Yes, okay.
A VC during a demo.
That's hilarious. Okay. Yeah, Ilya, were you going to say something?
Yeah, so I think I was going to expand a little bit on the API layer. So our kind of mission is to make the API just behave as any other web API, standard request and response, so that any web developer out there that you can hire for like $20 an hour can suddenly hook up whatever system you have in-house to a robot and do so without damaging equipment.
I like that. How do you, the biggest question that comes to my mind with that is, how do you manage state? Because it's complex. Like, I mean, you tell the robot, go here. You have to wait till it's there. There's some sort of like underlying action like thing.
Yeah.
So, and then with a REST API, it's very like you send something, it sends something back. How do you manage that? Does it open up a socket, or but then that gets more complex, or I guess how do you do it?
So we actually, so there's two layers to that. The first layer of your question on robot management is really using the behavior tree. So we fund Steve Masinski's work in part in Nav2, and huge fans of it. We use big chunks of it. Yeah, absolutely. It's fantastic work. And he has a behavior tree internal to Nav2. We have a kind of a larger one that controls other stuff outside of Nav2, but very similar kind of concept, similar inspiration. And that manages things like the client has requested 5 different goals, and halfway through it, they interrupt us and give us a new set of 4 goals. Should we then resume the original goals, or should we change, or what logic state should we take? So that's all on robot, and that's all function of our behavior tree.
So if
on the client side, though,
if I send two positions or something, it creates a queue.
Yeah.
How do you? But so to me, that's probably the behavior expected. But it may be like, oh no, I actually changed my mind. I want to go to this one. I don't want to go to the first one. There is
our
some
REST API.
Okay, yeah.
Our REST API, when you send commands, you have either a preempt or a queue option.
Oh, you guys have thought of this.
So we just provide all the we provide all of those knobs. And actually, a big challenge of building our API is we have hundreds of knobs we can adjust underneath our layer, and being very judicious on which ones we expose. So our API doesn't just become this enormous surface area that we have to test thousands of options, but just the minimum possible set that is intelligent enough to work in most circumstances.
Yeah. Oh, I like that a lot. Okay. So I really like the idea of these. So Ilya, is this your kind of, are you the master architect of all of this? Or how does...
I wish. Stefan's going to nod, but it's actually the engineering team. I'd say I do the least amount of engineering out of the team, thankfully. I think they're usually pretty happy when I'm not messing in the code, because my code tends to be experimental and tests and try out new novel things.
You're trying to get it. Yeah.
I'm very much that sort
Proof
of CTO
concept.
and engineer. Yeah. Exactly. And I can do things quickly and kind of test things out. But really, it's a huge credit to the engineering team, who really get it to a quality level where it works every time and is safe and is functional.
I like that.
And as much as I'd like to be that kind of person, I'm not nearly enough of that kind of person.
Well, the thing is, so I've seen companies where they have the master architect who builds everything, and they or like I mean, it could be build or it could be designs everything, but the result that I've often seen is that some of the like many of the decisions might be amazing, but some of the decisions were not, and they create unbelievable chafing, and then it's also very hard to onboard new people into the system. So if you're working with a team, that's probably a very good way to distribute it and get some sort of like consensus around the decisions, especially about the things that you're exposing, I would imagine.
Yeah. Yeah, and I'd say really my function is in a lot of ways to keep refocusing the team on let's make as general purpose of a piece of software as we can. Because often when we're working with a client, it's a very natural tendency to say, the client has requested X.
And
I'm
just
going
make
to build
X.
a function, right? Like I'm going to build
Yep.
X, and kind of I'll often come in and remind people like, well, X is a subset of this larger function that more people would want.
Mhm.
Let's build that larger function and teach the client to use that, because then it immediately applies to our whole fleet.
Mm-hmm. So, and you guys said was it eight people at the company
10
or something
people.
around there, 10?
Yep.
And so 10 people is almost everyone an engineer for this kind of thing, or
Almost everyone.
probably 8 out
10.
of 10? Yeah.
Yeah.
Okay. And how long have you guys been going? Just like, how long has this
2-ish
company
years?
been around? Okay.
Maybe 2.25.
Yeah, 2.25, about right.
How are you funding
Yeah.
the initiative so far?
So
you
we've raised some money, a decent amount. We haven't announced it publicly. More than a little, less than a lot. And we also like have this weird thing of like customers paying us in SaaS margins.
Amazing. Yeah, what a
Yeah,
thing.
yeah. I mean, like it's crazy after trying to do a big monolithic vertical robotics company before, where the lift to get to enough robots to be profitable
Oh, it's
was
huge.
okay, we need $40 million, but like there's a very real world where we're just like a profitable company this year, and I don't know how to grok that. My
Congrats.
roboticist brain is just very like upset with like, what do we do when more money comes in than goes out? I
You
think we
start
buy
to get into
Lamborghinis.
hardware, and then you can you buy Lamborghini.
That's,
into-
that's the money pit. That's
Yep,
the money
yep.
pit we shovel the money into. Yes.
Yep.
Okay.
Okay, I really like
No,
that.
it's funny, on that note, just a small anecdote. Stefan and I keep trading emails with our bookkeeper because we're always like, am I miscounting something?
This
Is
can't
something
be
not
right
with our business plan? Like it should be doing this, and it's like doing this, and I
Wow.
don't understand.
That's so exciting. For those listening, pointing up instead of down.
Yes. Yeah.
Very exciting to hear for robotics companies. Hell yeah, love it. What I guess another kind of fundamental question. I look on the website.
Yeah.
Why are you guys not open source? Is it because of the kind of competitive advantage of this? But why not? Why not?
So
I guess there were probably
Yeah.
discussions around this because you guys like Ross and things like this.
Yeah.
But what are you thinking?
I took this initiative from a good friend and mentor of mine, Ryan Garapi at ClearPath.
He's
Robotics.
wonderful. Yeah.
And he had told me this. Yeah, he's great. And he had said this a long time ago at ClearPath, and I quite like the logic behind it, which is we'll open source anything that is useful to the community and not directly harmful to us. So we actually open source as much as we can. A lot of the Nav2 stuff that we're trying to help fund, of course, is open source.
Yep.
We have a big discussion going on how to fuse GPS into Localist Robotics' Fuse factor graph localization system. There's some efforts we're doing there. We have an open container initiative that's fairly public about a bunch of the containers we use for build and infrastructure. The specifics, for example, of how our behavior tree dynamically generates nodes and make sure that they're all talking to the same system is useless for anybody else because we already have built enough that it's weird and special. And so even if we did open source it, nobody would care. And also would cause more problems for us than it solves.
Okay.
So whenever it hits those two, we try to, we open source anything that doesn't hit those two things.
Makes sense. I would wonder, like, I don't know. It seems like there's a few companies that are in kind of similar space. I like a lot how you guys have carved out the mobile robots space. I think that that was a very
Yep.
smart thing rather than like we're going to do all robotics. That to me seems like a good decision. I'd like to talk about that later. Um, but some of them are going open source, hoping for additional adoption. I guess maybe Stefan, how do you think about this? Like, would it accelerate adoption if you made certain parts open source, or even like you could even have like a high level Python library that just calls your API or something? Why?
Yeah.
How are you thinking about
I mean,
this? Or
to be
Ilia?
clear, the API is open source, by the way.
Oh, okay. I just don't
Like
see it on the website.
talking to the. Oh yeah. No, it's there. We've
Ah.
got to do a better job marketing it. But like any documentation and code on, and I've even posted some YouTube videos on like, here's how you talk to our robots, here's how you use them.
Oh, I love
All
it.
of that would actually make sense for customers, all open source.
Oh, hell yeah.
Throw in pull requests. We'd love to review them. Yeah, no question.
Okay, that's wonderful.
It's the underlying pieces that are weird and special.
As someone who's very lazy, I would expect at the footer on your website that there's a GitHub link and this kind of thing.
Yeah.
That's exactly where I went to look.
Maybe by the time you publish this podcast, that will exist.
Okay. Because that would be great. Okay, so I misread the website in that case. That seems awesome. And okay, so I guess why are you carving out the niche of mobile
Yeah.
robots only? Why aren't you doing arms? Why aren't you doing all sorts of other things?
Yeah, I mean, so I think that has to do with a lot with like what we've done before. I'm not an arm guy. I'm not a quadcopter guy. There's also a lot of people wanting to do arm stuff like this. There's a lot of people doing quadcopter stuff. In both of our past experiences, we rebuilt stuff that we had already built and other people had already built a whole bunch of times, and then found it
Oh.
wasn't incredibly reusable. So previously, when I had like a vertical self-driving truck startup, every time we'd get some big piece of press, I'd get a bunch of inbound from random industrial companies saying, hey, air quotes, you've solved autonomy. If we pay you $8 million, can you automate this super niche piece of equipment that only 8 of in the world exist and no one else uses, but is really valuable to us and we can't hire operators? And because of how we were architected as like some big monolith vertical thing,
Was
we
very
basically always
Mhm.
have to say no to that. It would be an entire pivot. It would be throwing out 75% of the code base. And like if you look at the big OEMs who built autonomy multiple times, like some of them, one of them who likes the color green, has built autonomy at least like 15 or so times.
Wow.
None of those rebuilds have used more than 25% of any existing code base. None of them have cost less than $10 million. None of them have been
Whoa.
completed in less than 3 years.
Wow.
This is a like super key problem and is a big part in our belief of why the robotics industry sucks so hard. Because like people want robots to grade construction sites so they can start building, or to till fields, or to spray fertilizer on crops, or to do whatever. And to even look at a use case like that, pre-Polymath, you might have to hire a consulting firm $5 to $50 million to build something that might only work for a demo day. And like
It's crazy.
that does not build a good, strong industry. So like the ARM people have done cool stuff in manufacturing. The drone people have done some cool stuff in toys and inspection and whatever. But for mobile robots that move through the earth, like we need to make it not so hard to create value.
I think that's a great idea. And it's so cool to me that, so going into like the founding story of coming to Polymath Robotics, you guys, so Stefan, you were doing a highway autonomous car startup or autonomous truck, or what was it exactly?
Yeah, so
Okay.
Starsky Robotics, we were doing self-driving trucks. We did we started with a similar thesis as Polymath, that robots are hard. The way we're
agree.
overcoming robots being hard is we do autonomy on the highway, where it's a relatively constrained environment. We do teleop and the first and last mile, where it's kind of chaos. And then to make that problem easier, we control our own routes by being our own trucking company. And at the time when we were making a lot of hard technical decisions, 2017-ish, basically no vendors would give you any part unless you were willing to sign something that said you never rely on it for a driver out test. So as a result, what Starsky
I don't
became was
understand.
this.
I don't
Yeah.
understand that.
Yeah. So we talked to LiDAR companies, we talked to the Velodynes, we talked to
And they were like, you can use our stuff,
retro-
but don't use our stuff for real things. Is that what
Yeah.
it basically was?
Yeah. Yeah. Legitimately, that was what it was like. So
Wow. Because it was legal reasons, they don't want to be affiliated with it, I suppose, if it goes poorly.
It wasn't illegal, it's just kind of fear. I mean, I think it's important to note in on-road autonomy, I haven't done an actual count in a while. I think there's 5 companies ever that have taken a person out on public roads. Like something like that. And like there's in the range of probably $25 billion invested in the space. It is mostly a not real industry. Or I think actually the number might be $100 billion invested.
Bonkers.
But so previously I'd done that, and we had, because of robots being hard, we grew into this Frankensteinian monolith vertical company where we had to do an incredibly not built here syndrome hardware stack, an incredibly not built here syndrome autonomy teleop safety stack, software for running your own trucking company, and then running a trucking company. I'd have to go for meetings where like,
it's hard.
Yeah, just really, really hard. And I don't know if most people can be successful in that type of business. If you have to
it seems like you
everything.
have to be like 4 CEOs at once to do that kind of thing. It seems like so many different businesses and industries that and I don't know what your trucking experience is, but like you have to be a trucking business manager as well for all these things. So that sounds to me tremendously difficult.
I think one of the main reasons that company didn't raise a Series B was because I was less good at talking about the financials of a trucking company than a Fortune 500 trucking company CFO was, which was a hard thing to be good at talking about right after explaining safety engineering to someone for the first time.
Yeah, totally. Yeah, that's so interesting. Okay, so, and in that experience, you saw a bunch of these, like it'd be like, okay, you get press. Then it's like, oh, you've solved autonomy for these problems. Some people see it and then go, hey, we really need something similar to that. And you saw these over and over again. And this is how you've kind of come to Polymath. Basically, and the idea.
Big enterprise believes in autonomy. Like big mining companies, big farms, big factories, they all have labor shortages. They've seen enough headlines about how self-driving is here. And they're looking around and thinking like, I can't hire people to work in my lumber mill. I can't hire people to work in my port. I can't hire people to work in my rail yard. Maybe some robots could move this stuff from A to B. And before Polymath, maybe there was someone who happened to be building the right solution on the right vehicle, like a perfect gated corner of a vertical lineup, or maybe you had to hire a consulting firm to build you something from scratch.
So you are allowing companies to build up around specific vehicles that big companies are using, and you provide a lot of the research, basically the infrastructure that they need to build to do it.
We give them a code base that will just work. We can connect them with people to do the retrofits, and we can take commands from whatever their weird system for running their business is.
Cool. That seems so. Go ahead.
I'll give you a fun illustrative example, which is my favorite one. We haven't done this yet. I keep hoping that eventually we'll get to this mission.
I'm hoping to.
There's this problem in metal recycling where if you recycle a bunch of metal, you end up with this big molten pot with a bunch of slag on the top. Once you dump out the useful metal,
and by
you end up
big
with a
molten
pot full of slag.
Like imagine maybe a cauldron with a radius of like 10 feet. And like maybe like
a backyard pool,
like something a villain would fall into at the end of a
exactly.
Like what kills the bad guy in Terminator?
Crucibles.
Yep.
Yeah. So it's this enormous crucible, and what they have to do is they have to pick it up, drive it outside to a particular dump site, and dump it over.
Mm-hmm. Dump it over.
And there's a purpose-built machine. There's a purpose-built machine that drives this thing, and it's a heinously dangerous job. Because if you accelerate too quickly or suddenly brake or have a bump, liquid metal splashes the vehicle and catches on fire.
And you die.
The vehicle's and you die. Yeah, the vehicle's purpose built that the like liquid metal fire death is at the back, and the propane tanks running the vehicle are all the way at the front to make sure that as far away as possible. There's probably like 200 of these vehicles on the planet, but they're so ludicrously dangerous that like perfect case for autonomy. Same spot every day.
Yep.
Same exact conditions.
Oh my God.
Perfectly designed space.
And the
But
person
the guy's
who does
getting
it,
paid a ton of money.
I was going to say they probably make
because it's dangerous.
$300K a year or something like
Well,
this.
they also a thing, Ilya. I don't know if I've
light
told
on
you this.
fire at a high rate.
And another thing I learned about this use case recently is it's also incredibly carcinogenic. So even though the guys might be making $300K a year, after like 10 years, they have all sorts of unpleasant cancer.
Yeah,
all the cancer. Oh my
so
God.
if you think about like vertical autonomy for that solution, there's 200 of those vehicles in the in the world. Does it make sense to spend $50 million to learn how to automate just that? Like, it literally might be cheaper to just give people cancer than to build one-off autonomy for that use case.
It has been.
Yeah,
that's why they've been doing
the market has accepted cancer over the status quo in robotics.
Oh my gosh.
But meanwhile, it's the same steering wheel, the same gas and brake pedals, like a human's driving it the same way that we drive our test tractor. So there's zero reason we can't stick a few sensors and actuators on there with a retrofit partner and then have day one perfect autonomy.
Yeah.
Just like we have on the rest of our fleet.
That's super cool. So one thing that I don't fully understand is the sensors. So you said earlier that you use a lot of the sensors that are on these vehicles. I would imagine you want additional ones for autonomy. So like, I would think vision would be really useful. Maybe LiDAR would be kind of useful. You might want an IMU or whatever. So do you have like a little box of sensors you put onto these vehicles sometimes, or?
No, I wouldn't say
case by case.
I would say, case by case. But generally speaking, the main ingredients are some sort of feedback from our vehicles. Just even a live or not alive state is useful. So on that 1997 bulldozer, we at least know the engine's turning over.
Yeah.
So we have some concept of health. But even better than that, if it has a speedometer, feeding in the speedometer is a nice ground truthing for us to correct.
Okay. And do you do that?
If we're standing still, we're standing still. Right.
Yeah.
So even that layer of data is even though it's coarse, it's useful for us as a error checker for everything else.
Do you tap into the vehicle system in that case, or do you put a camera to just look at it? Or okay.
We tend to just use the CAN bus if it's there. If it's not, we'll put a little encoder on the. Again, it's not us, right? It's our partner teams, our integrators. Put a little encoder on part of the drive shaft or camera staring at the dashboard, worst case. But that one usually the update rate is eh.
Yeah. And then we'll have a bunch of different sensors added depending on the use case. So it could be LiDAR, it could be stereo cameras, could be radar, could be whatever. An interesting thing that we found is people have really strong opinions about sensors. Like, if we were just a LiDAR shop, we would have fewer customers than we have right now. If we were a never LiDAR shop, we would have fewer customers than we are right now. And I think
you got to support them all. Yeah.
Yeah. And like the thing is, when everyone builds their robot as like a monolith, what happens is there's so many crappy parts of your code that at some point, some demo was ruined because a Velodyne LiDAR wasn't behaving properly. Or at some other point, a demo was saved because, oh, look, we replaced that LiDAR with an Ouster or replaced it with a Z camera. So now every robot forever needs a Z camera on it. And we need to be able to work with both of those strong opinions. And my hunch is every listener here has some sensor out there that they hate and another one that they love.
Yeah, that's so funny. Yeah. And you guys, it makes sense. So catering to, or not catering to, but allowing all of the different sensors that people might want to use. Okay. So that's really cool. And so a thing that is very interesting to me about this is that what you guys are doing, it's like, okay, so you mentioned those 200 vehicles that are doing the super dangerous metal hauling, liquid metal, terror. That just sounds awful. But so you have 200 vehicles that are doing that. That problem does not, like some companies want to pay a lot of money to do that, but it doesn't make sense for a venture capitalist to be investing in a company that does that, because you have 200 of these vehicles. It's not going to grow that much. Maybe you can apply it to other things, but they're looking at the market that's going to buy right now. And so it's really interesting to me because I feel like with a lot of the robotics companies that I see is they pick one little vertical like that and
Yeah.
then they go build something in that.
Yep.
And it's not that attractive to venture capitalists because they want to buy in at a fairly late stage where they go, oh, you clearly have market traction, whatever, and you need this big injection of cash for doing something, but I want to see a 10 or 100 times return in 5 years or something like
Yep.
this. You guys are doing it kind of clever where you're kind of agnostic to all these problems and you let other companies go and be profitable on those vehicles. Um, but there's a lot of growth that you guys can do, which is quite exciting, I think.
Yep. And we can make a lot of bets in a lot of different industries. Where if our customers are successful, we'll be successful. But we can simultaneously make bets in metal recycling as well as forestry, as well as ports, as well as this, that, and the other. And kind of as long as some people build robots that create real value, we can make sure the robots work. But in a lot of these use cases, the real value comes from like what they're told to do. So like if you think about like robots in a port, for example, driving a yard truck with a trailer is not special. There's something like 5 to 15 yard truck autonomy companies that are doing just that. There's an incredible diversity of yard truck manufacturers. So if you're vertical, you have to figure out which ones you're going to integrate, which ones you don't. The really, really important thing that yard trucks do is they get commanded around by some system that manages a yard management system. And that system might be configured so that, maybe there's 5 lanes going from north to south. And on Wednesday morning, a big ship is coming in. So 4 of those lanes are coming away from the ship, where 1 lane is going towards the ship. And an hour later, you reverse the traffic the other way around. And that way you can get the ship empty 2 hours earlier, which means you can have 5 more ships visit per year, blah, blah, blah. That's the stuff where you're actually going to make $1 billion with robots. If you're reinventing our part of the stack, you're missing it.
What you mean?
Like, because like a lot of teams doing yard trucks are spending all their effort building what we build and not like intelligent yard management based on machine learning statistics and blah, blah, blah. And like, that's really the cool part of being a yard truck company.
Yeah. So yeah, I agree. So if you do the super big tasks made by these super big consumers, you can be rewarded handsomely and be $1 billion robotics company.
Yep. And if your autonomy stack sucks, you don't get any of it.
Yeah, and you have to build that, and that's a heavy investment initially. So you guys are helping enable that, which is quite cool. Now, I would love to hear kind of what are your ambitions for this company and I'd love to hear both of your perspective on this, to like, where do you want this to go? Because it seems like a slightly new business model to me, which is quite cool. Maybe we start with Ilia. Like, where are we going in the long term? Like, how do you see you guys growing?
Yeah, from the technical standpoint, I think the interesting part of our business is, again, drawing that operating system kind of comparison. You buy Windows to then run Excel or games or whatever, right? I think because we're really focusing on A, software, and B, only motion software, and the edges of what motion means will blur over time. Yeah. So concrete example really quickly, that bulldozer will control the bulldozer, will control the blade somewhat. But if a builder says, here's a site plan, dig the site plan autonomously, we'll probably partner with somebody who specializes in translating site plans to blade control to whatever, and we'll drive it and work with them. So I think the technical interesting part is we're building a foundation to then have kind of a web store. If you talk about what Universal Robots did, I really like what they did for arms, right? Is like, here's the arm, here's the foundation, but like, here's 50 different companies that will take our arm and then make apple picking or make CNC machine tending or whatever. It's the same thing, is take our autonomy core and then build on top of it. And here's a bunch of vendors that will sell you pre-baked modules to do agriculture with autonomy, to do mining with Polymath autonomy. We can do those pieces, but I think we'll never outcompete thousands of people using our stack.
And we don't know how to run a mine. We don't know how to run a forestry operation. We don't know how to
You
run
saw
a
this
port.
with your trucking company, I imagine. That was
Yeah,
probably a hard
I had to
lesson.
learn how to run a
this.
trucking company, which turns out is not simple.
No, everything's hard when you get into it, I think. Yeah. Okay. So I really like that point. It's interesting to me how it seems like so many of the companies that I've talked to on this podcast, it's like the vision eventually scales to being something like an app store with this kind of thing where you allow the functionality, you provide the core
Yeah.
platform, and then people can build off. And that sounds like where this may go. And it's just, to me, it feels like an exciting time in robotics that maybe this
Yeah.
will actually occur. Because it seems like a lot more people are working on it recently and have good go-to-market strategies to get there for this kind of thing, at least from my perspective.
Yeah, absolutely.
And Stefan, what do you hope?
Yeah.
Like, where are you? What are
So-
your ambitions with this?
Yeah. So my last company, Starsky, was my first ever startup, and it was really hard. And at the time, I didn't know how much it was hard because startups are hard, and how much it was hard because I was building robots and running a trucking company and writing regulations.
You were
and blah,
5
blah, 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 blah.
CEOs at once. Yeah, for
Yeah.
sure.
And then after that, I went and hung out with some SaaS companies, and like, holy crap!
Yeah.
Like assuming, Audra, that you've never worked at just a normal SaaS company, like, DocuSign 5.0 SaaS company. The way that
Yeah.
you start a SaaS company like that is you have a product-y, salesy CEO. You have like a generalist 50th percentile engineer who can kind of talk to people, but can mostly write glue code. That product guy figures out like what you should kind of be building. The glue code engineer finds a bunch of microservices, ties them together to build it. And like theoretically in 5 years, they're each worth a couple $100 million. Whereas in robotics, it looks like the world of PCs back in the 70s, where like screw Steve Jobs, you need like Steve Wozniak, who can like code in binary and design his own circuit boards and build GUIs and make them kind of
Yeah.
useful. And like without an army of Steve Wozniaks, you have no product. Like the
Yeah.
robotics industry will never get beyond that phase if everyone has to keep on building point-to-point navigation. If Polymath can enable the market to just focus on things that work, and like, it's still not going to be as easy as DocuSign 5.0, but like if Polymath makes it so that building a robot is as easy as making a website in 1998,
That's
then
a huge
like
win.
we're going to start to actually have robots. We're going to actually start to have cheaper, better food. We're going to have cheaper materials. We're going to have cheaper cost of living. We're going to enable a whole lot of the world to live as nice as we do in the West. And I think that like along the way, if we enable that, we'll make a whole bunch of money and build a cool thing. So that's what I think.
Good
That's
for the
what I'm
world.
hoping for.
Good for you.
Yeah.
And exciting problems. Because to me, what it seems like, it's a lot more exciting than this, but it sounds a little bit like a lifestyle startup in some way. And what I mean by this
What do you mean?
is, well, so what I mean is that you get to kind of leverage the power of like the SaaS model in some sense,
Yep.
where you don't have to be, you're only one CEO at this time. You're not
Yeah.
5.
Yeah. Yeah.
And so it seems like it's a bit easier. You guys are profitable early, so you're not like lighting the ground on fire behind you and running like you
Yep.
would be if you're taking investment. Maybe lifestyle isn't the way to say it, but like it's more on
Yeah.
your terms in a sense.
Yeah,
is
we
what it
get
feels
to
like
be-
to me.
You accidentally slandered Stefan there by using the lifestyle term. No, kidding, purely kidding. VCs will use lifestyle business as like something we should
Derogative?
invest in,
Oh,
Yeah.
which
yeah.
is not like
Because
not
like,
what
don't
why
we're
would
mean it
you
that
ever
way.
want to just like be rich and have a nice life? That's terrible.
Yeah, exactly. No, you have to make
You should
them
be
rich
5
first. That's your
CEOs.
goal.
Yeah.
Yeah, exactly.
I mean,
Like,
when you're
what's
real good,
funny-
you are 10 CEOs. Yeah.
Like what's funny is like compared to a normal full stack vertical robotics company, this feels incredibly easy. Compared to
That's
my
what I
friends
mean.
in SaaS, this is still incredibly
Really hard.
And I think like even, in 10 years or so, some of the modules that we sell as individual products that like as a part of our stack, there will be $1 billion companies that just do
Come
things
out
like
of that.
Slam or just do just through really clever path planning for diff drive vehicles. Like there will be industries like that, but right now it's rather radical to say, oh, we'll just take the autonomy core off your hands.
You mean make it so they don't have to do that? Yeah.
Yeah.
So you can just
right now
use
that
it.
right now that seems radically easy. In 10 years, it will seem radically hard.
Yeah. It is amazing how that seems. Like building a website now is still difficult. Like if you want to build a fully featured SaaS stuff, like a lot of my side projects are SaaS stuff. And like it's still a lot of work. But it's so much easier than robotics projects, which is just bonkers.
Let me tell you a version of that. I had a side project, an e-commerce side project a couple of months ago, that I've never actually publicly in any setting admitted was me. So this is like an Audra and Ash exclusive.
Cool. You heard it here.
Yeah. So early last year, I got wind on a WhatsApp group for YC founders that like something weird was going on at SVB, and like a panic was happening.
That was Silicon Valley Bank, that big one that collapsed a while ago. Okay.
Yep. And I panicked early. Like I panicked on that Wednesday night, which meant we got our money out like relatively soon. But while I panicked, I had a dark joke that like the Silicon Valley Bank run was kind of like a marathon run. So I went on Fiverr and I basically paid a Fiverr, I think $20 to make a t-shirt design for what a bank run marathon t-shirt would look like. So $25. I bought the domain name, I think SVB Run 23, which sounded like a good marathon run. So that was $10-15. And then I set up a store on Teespring. And I don't know if you're familiar with Teespring.
But Open Robotics uses it for distribution. Cool. Yeah.
So for the listeners who don't know Teespring will make it easy to do like a screen printed shirt business where you can just upload a shirt design and they will print the shirts and ship them and do all of that. So I paid for the premium version of Teespring for I think $20. And for $75, I had an e-commerce site with a line of like 9 different takes on SVB Bank Run marathon shirts, which I posted in a handful of links. And I suddenly had an e-commerce site that got me, I was a top 1% Teespring creator that month.
Wow.
And like, if that was a real business, that could be a thing that I did. And it has nothing to do with robotics in terms of how hard it is. It is a.
Can I add a little bit of? Can I add a little bit of late breaking news? This will be a surprise to Stefan too. In the full circle of e-commerce, you were also immediately ripped off by a random Etsy seller. This is your exact design, and there's some Etsy seller who ripped it off immediately.
What a schmuck!
Yeah, that's on Etsy. That's what
I'm
saying.
What a schmuck! There's also another person ripped me off on Teespring, and Teespring refused to do anything about it.
Yeah,
but
I think like e-commerce life. But
like you can literally set up an e-commerce store without like even opening up Photoshop to make your own products. Like robotics is not going to look like that for at least 20 to 30 years. But like that's if robots are going to be a real part of our life, if robots are going to bring us the promise that I think everyone in this conversation wants them to bring, they need to get a lot easier. And that's what we're hoping to do.
Hell yeah. Okay. I really like that. So you guys are 10 people now. What's
Etsy
the,
store.
I know that's so freaking funny. Well, you made it. You made it that you got ripped off. That's great.
I think we need to open an Etsy store for Polymath shirts, by the way, like the one that Stefan is wearing right now.
Yep.
For the listeners, he's wearing a shirt that just says Total Ross Bag on it. Because we had an internal joke at Polymath that like, oh, anytime anybody would do something bad, it'd be like, you Ross Bag. So
nice.
Doesn't work as well with MCAP
near you. Yeah.
MCAP doesn't seem
we also have
as
MCAP hats.
Cool.
We have MCAP hats too.
I like it.
Anyway.
Hell yeah. Let's see. Lost my train of thought with this. That's very funny, all the swag and everything. So what's the growth plan for this? Like, so you guys are 10 people now. That line is going up. So it sounds like you're profitable or becoming like you'll break
We're not
even
profitable yet, but it seems like we will be
on the trajectory. I mean, 2 years and starting to move in the right direction. That's wonderful.
Yeah.
How do you imagine growing, or like, do you need many more people for the work you're doing, or will it be like there'll be like system integrators that help push it out, and maybe you can focus on a few promising
Yeah.
vehicle areas, or like what are you thinking for how to grow in the future?
So it's funny, like right now, more of our problems are like business problems than they are robotics problems,
Technical
which is
ones.
also
Yeah.
weird. Like I didn't think that could
What is
happen in
this? Yeah.
robotics.
I
So like we
know.
need like we're essentially we might go raise again, or we might just grow to profitability, depending on how the VC market's at, which could be a whole other conversation.
Hmm.
But if we suddenly had 10 more people, probably half of them would be business people doing stuff like account
Wow.
management and like splitting functions into other things.
It's interesting to me because it feels like with a lot of hardware companies, say like medical
Mhm.
device companies, as the company moves across time, the staffing changes pretty significantly. So
Oh,
you have a lot of like researchers and our engineers at the beginning. And then once they make something, it's like, okay, now you need way less of them. And now you need like a
yep.
big legal team or certification or I don't know,
Yeah.
whatever, then marketing and who knows. But it seems like you guys are kind of going through that as well, where, okay, we
Yeah.
had a bunch of engineers, 8 of the 10 were engineers. Now you
Yep.
probably need another 10 business people.
Maybe another
It's
5.
interesting. Okay. Well, something like that.
Well, and I think the key metric that I convinced Stefan over time to start tracking is our robot to employee ratio. I really
You
like
mentioned
my
it right at the
goal is to
beginning.
get to like
Yeah.
10 to 100, yeah, robots to
Wow.
employees.
Well, and
And
also
that
when
will
Ilya says
require
that, Ilya actually means different types of robots, not even specific robots.
not even
Ooh,
copies.
I
Yeah,
love
because
it.
copies to me are like, whatever. It's the exact
Yeah,
same
Yeah.
robot.
they're free.
Uh,
You already have it working.
yeah, exactly.
But I
It's
guess those
software, whatever.
1%
Yeah,
cases will come up more for this kind of thing.
yeah,
So
of course,
not totally free.
of course. No, yeah. I'm being a little
Facetious.
facetious,
Yeah, for sure.
um, but yeah, no, I think as we grow, I think we will still need quite a significant engineering presence because one of the reasons we sell ourselves as SaaS is that we're continuously improving every piece of our stack. Especially, actually, we can get into this in technical detail in a bit, but the machine learning part of what we do is actually a very small, kind of thin sugar sprinkling on top of the cake in a lot
Mhm.
of ways, where it's a key differentiator in some ways, but in other ways, actually, there's so much fundamental to do at the underlying layer that we got to get that
Nailed
large and
down.
expanded first. Yeah,
What's
Yeah.
what is the
I think
machine
to
learning part of your? Because we haven't
yeah.
really talked about
yeah.
that at all. I don't know what
Yeah,
it.
I'll give you a concrete example. So we have an application in forestry,
Mhm.
and we have a lidar system. And you can imagine in a dense forest, you're not getting very much GPS.
Mhm.
So there's a lot of complexity on localization, orientation, and heading management, obstacle avoidance, those kind of things. Um, but from a lidar point cloud, you can't really tell if the thing you're seeing is a bush, which you're supposed to just drive right over because you're a multi-ton vehicle, or is it a boulder, which if you try to drive over, you'll damage your drivetrain,
Mhm.
right? And that sort of stuff, that's where ML will come to play a role with image data or LiDAR data, which classical algorithms can't do quite as well. You can think of some heuristics maybe, but honestly, like any
Yeah.
heuristic you can think of, a bush and a boulder will look similar at some point from some angle. Whereas camera data and humans can tell them apart pretty easily.
Yeah. So
And that's a case where that extra guidance, even though all the underlying pieces to navigate and pathway and obstacle avoid, the extra guidance allows us to not make suboptimal decisions of avoiding a bush when we could just drive right through it.
gotcha. Yeah. So these are in your modular framework. These are components you can add that might improve applications. Maybe you say, okay, I have this
Exactly.
path planning, and this path planning effectively has a plugin or something that says, is bush or not? Is bush or rock or something like this?
Yeah.
Yeah.
And you can have machine learning determine which one it is. So that's interesting that you guys are getting into that.
But like a
Any? Oh, go ahead.
relatively weird opinion. Yeah, but like a relatively weird opinion that we have is in robotics, there's a lot more ML in the world of robotics and the market of robotics and the products of robotics that you can buy. ML is a lot more commodified than like really good robotic software that is reliable and turns on every time and spits out metrics for why it doesn't work. And deployment infrastructure so that you don't have to send people to West Nowheresville to go fix a robot in the middle of the night with a 8 hour notice, or controls engineering that can smoothly drive vehicles
Oh, totally.
of various different sizes. And I think I think there's this weird market dynamic going on where like the VCs are really stoked about like machine learning because they just got to kind of see what like LLMs can do and like a way that they can directly interact with. And they're pretty amazed. Whereas like, I don't know, I'm pretty stoked by robots that turn on every time. And I know how few large robotics organizations that is true for. So we're focusing a lot more on those kind of fundamentals.
Yeah. No, I think that's smart. A lot of the, like, I don't know, it's very interesting to me because there are some things that like machine learning seems well suited for. But there's a lot of things where we think it's good, but then it isn't when you try it. And like the problem with robotics now really seems to be a lot of exceptions pop up when you bring robots into a less structured environment.
Yep.
And those, it's very hard to imagine a lot of machine learning doing very well with a lot of those. I don't know, I'm doing some thorny coding for work, and it's like, it's complex. There's all sorts of hidden stuff that's hard to understand. And I'm asking LLMs advice on how to do this kind of thing. And all their advice is garbage for this kind of thing. It's like, I've actually gone to stop looking at these and just Googling because it is, it's like it will look convincing and it looks like it's going to work. And then I try it and it just doesn't. And I can imagine that this pops up a lot in robotics applications.
So the exceptions thing is actually part of why off-highway or like large vehicles are really neat. So basically all of these different industries, from like ag to mining to whatever, suffer labor shortages. They fundamentally
everything is suffering labor shortages.
Spend enough money to hire enough people to do the work. So as a result, they need a smaller number of people to do the same amount of work, which means that machines get bigger and bigger and bigger. When machines get
it's like
bigger,
shipping containers that are just absurdly large. Okay. Yeah. So they make one person do what 20 used to do because they just have a 20 times larger machine, this kind of thing. Okay.
And what's cool about that, first of all, if the machine does more valuable work, you can spend more money on sensors for it. So like that's useful for us. But more than that, big machines are really dangerous. So they drive more cautiously. A 500-ton dump truck,
which is interesting.
Basically, the most valuable machines in the world to automate are among the easiest.
That's wonderful. Yeah, because
the giant mining truck or the molten metal transporter is way easier than Astro in your house. Like orders of magnitude.
And like the 500-ton dump truck, like I think Caterpillar gets $1 million a year for each one of those. In recurring SaaS.
Wow. That's so crazy. What a funny thing that just it makes complete sense, but I hadn't thought about it, where the ones that are the most valuable, and then also like you could strap expensive sensors on them, and relative to the total cost of the thing, it's nothing.
And they're big, so there's a lot of space for them. There's a lot of power. There's a lot of storage for compute. Like all of your problems get easier at larger scales. There's also an interesting, to harken back a little bit to where we see things going. As our type of approaches, or hopefully us, get more and more successful, you don't need these large vehicles anymore.
You can go back to small.
One of the labor shortages, you can go back to small, right? And which kind of dovetails nicely with sensors getting smaller and compute getting more efficient over time. But there's a funny kind of story I heard from the South African mining industry, where they're very active in mining. They have good regulatory body for autonomy, but they have a black market for tires for these large vehicles, where getting a new tire, if it blows a tire, is like a 4-month process.
Whoa.
And in that time, you've lost many millions of dollars.
That truck might be responsible for moving $10 million of material a day. So if it's out of commission for 90 days,
money.
Yeah, we've lost a lot of money.
Enormous money. And so the incentives are so high that they have people running around stealing tires from each other. Because like at that point, you'll pay a group $1 million to get you a tire, no problem.
Wow.
So and these size vehicles are so large that they get shipped in pieces to the site, assembled on site,
by
work their entire life on site,
technicians,
and then left there. and then left there.
Wow.
When the site is done, the vehicles are buried.
They're not even worth
You don't have to
transporting.
you don't have to do any of that if you have a smaller vehicle.
Yeah.
Yeah.
You just put them on the back of a flatbed truck, and you just have like, instead of one giant one, you have 10 medium or 30 small size. If
And
one of
what's
them
neat-
breaks, you only lose 1/30 of your effectiveness.
And when they
Yeah.
get smaller, they get easier to electrify too.
Oh, that's a cool point.
Yeah.
Okay. Which that's desirable because it's just clean, easy to maintain. You don't need
Yeah.
big, like diesel, high pressure,
mean,
hydraulic, whatever.
I mean, if you like the idea of sometimes there being snow, more electric vehicles seems nice.
Why is that? That doesn't make
Sorry.
What?
If you like the
You're
idea of
making a
not,
climate change
being
joke.
facetious.
Yeah.
Ah,
yeah.
it went right over my head. Yeah. Still don't get it.
What-
It was-
what wasn't my best climate change joke?
One thing that's interesting to me, so Electric Sheep, the first interview that I had on this podcast, they also had a similar thing where they were instead, like the constraint was exactly as you've said, where they were trying to do lawn mowing and companies have fewer people, so they get bigger mowers, and bigger mowers are more dangerous, but they probably also go fast for that because they got to mow quickly. And so what they said is we can remove that assumption and have a whole bunch of small mowers. So that seems like where it goes eventually. But you guys are preparing for the near term where you can automate these single large vehicles and get a lot of bang for the buck there. And then as you automate, I suppose then we can remove that restriction as we build more robots and things like this to,
Yep.
yeah. So you build, basically, we need more deployed, and the new generation can start to be smaller ones that can then use the thing. But we get
Yep.
to start on the big ones, and it's easier, which is just glorious. Like, what a great
And
thing.
you need to deploy on the equipment people have today. Like I've heard of
Yeah.
autonomy programs that, like for some use case, have gone to customers we've talked to and said, all right, cool. For us to save you $500,000 of labor costs per year, or $750,000 of labor costs per year, step one is you need to buy $15 million of new equipment because we only can work with this one specific type of vehicle.
Bonkers.
And yeah, weirdly enough, those autonomy deployments never happened. So like we have to
Yeah.
be able to meet the market where it is today on the vehicles that it's using today. And then as the needs around having physically present labor go away, the market can move towards smaller, more electric, more nimble vehicles.
Mm-hmm. I like that a lot. Yeah. And then you don't have, I guess then you can remove the black market for these tires and things like this because smaller
Yep.
ones are probably easier to procure. That's great. Okay. What a cool thing. So we touched a little on AI and machine learning. What do you guys generally, like, just because it's so topical,
Yeah.
what do you guys generally think about all the generative artificial intelligence stuff? And also, I mean, there's a lot of other exciting work where it's like learning from demonstration. There have been some cool
Yep.
demos lately. And even like end-to-end robotics learning stuff where they do a lot in simulation and then learn the final things in the real world. What do you guys think there? Maybe start with Ilia? Or Ilia, do you want to think for?
I think
No,
I mean,
no.
look thoughtful for the thing.
I think there's a lot of usefulness there. As if I put it on purpose, eh? No, I think there's a lot of usefulness there for kind of high variability tasks, like working in the home again, or high degrees of freedom manipulators, where you can't by inspection or algorithmically test every possible outcome.
Mhm.
So image generation, for example, why it's so interesting in machine learning or generative networks for images in general, is that the image space is so enormous that there's no kind of algorithmic approach that can generate enough data. So you have to have these probabilistic machine learning based approaches to actually get anything reasonable.
Definitely.
There's no good way to do it otherwise. Because the data content of an image that you're seeing right now is incredible,
Mhm.
right? And so for those kind of use cases, especially in robotics, I think it's very promising because we don't have enough compute or algorithms to solve it any other reasonable way today. However, again, in our space, where it's very much the opposite of very well-defined kinematic models in somewhat controlled spaces, I find the ML approaches are a little bit overkill, and they tend to overfit to their space.
Mm-hmm.
Kind of the answer I give people is they say, well, you should use photorealistic simulation and test all your stuff in sim, which we do use simulation, but we put almost no effort to make it photorealistic because
You don't need it.
the amount of money, A, we don't need it, but B, the gap between us and somebody like Tesla is several
Bonkers.
tens of billions of dollars. and they have the resources and are at that bleeding edge where every incremental dollar makes a difference.
Mhm.
Whereas us, we don't need $1 billion to make a 90% difference in what we're doing. We only need a fraction of that. And so it just wouldn't be a wise investment for us at this time in our use cases to put the bulk of our effort in ML.
I also think with the types of vehicles that we're driving, they're supposed to do very discrete things. They're not supposed to do fuzzy things. They might be
Mm.
like told to do what they're supposed to do in a fuzzy way, right? Like it might be that someone says, hey, yard truck, can you bring this over to crane 72 right now? Or they might say, yard truck 14, bring this to crane 72. Like both of those two things should lead to the same discrete action. But the way that we drive that yard truck through that port, the speeds that we drive at, the way that we
All
interact
very
at
fixed.
and if it's not fixed, it's terrifying.
Oh yeah, totally.
Like, you don't want to wonder, like, why is that bulldozer doing that thing it's doing towards me?
Yeah.
like it needs to be like, oh, it goes exactly there. And if it's going somewhere else, something's really bad.
It'll probably
so-
stop. Yeah.
So like
Hopefully. Yeah.
for our application, where I'm really excited about the broader, what people are currently calling AI. What I'm really excited about it is for the UI, is for the interaction between our highly deterministic systems and like fairly non-deterministic people. So whether that's voice commands for robots to do things, whether that is using an LLM to scan an organization's manual to figure out how their facility operates and to try to turn that into a list of Booleans that we could have a person read through and see if
As
they
a
make
great
sense.
starting point. Yeah.
Yeah. Like that probably, like that second thing I just said would probably save 20 hours of stupid meetings that no one wants to be in for implementing 100 robots in a multi-billion-dollar facility. But like, I don't think, us figuring out a novel path based on the vibes of the transformer model across that facility, that's probably not going to be the right strategy anytime soon.
Yeah. Oh, what a thing. Yeah, it's the thing that's really interesting to me with it is a lot of times, so these big companies where they have this huge handbook and they tell you how to do something and they want it done in that way. And if you have an LLM go and make an initial thing, you still have to pay the expert to go and confirm its results for these kinds of things. It's like,
Yep.
I've been thinking about this more broadly, and it's like, I feel like programmers, I feel like copywriters, all these different things that we all thought were going to be automated by ChatGPT, I think they're safe for a while because you want that person to validate it. You need that check on it to make sure it's reliable and does what you want. And then with programming especially, it's like, and if you want to build off of what you've done, now you have to give it back to the thing. And if it says it can't do it, but it's still doing the wrong thing, it's just interesting because a programmer could probably figure it out, but an LLM may just get stuck like it is on the problem that I'm trying to
No,
use
what's
it
useful. What's useful for us is like the guidebooks for a lot of our machines are written. They're kind of written like Booleans for idiots, because oftentimes the managers of these facilities don't have the world's highest level of respect for the vehicle operators. So like I've read a manual for a particular facility where there's vehicles that lift up 30,000 pounds and then drive around with 30,000 pounds and then move it. And there's a list of like maybe like 50 rules of operation for when you're driving these vehicles. And one of them was like, if you've lifted a load and you're in reverse and you see someone standing within 100 meters behind you, turn off the engine, get on the radio, ask for help. If you're driving from here to there and this gate is open, turn off the engine, get on the radio, call for help. And like there are rules written like that like an LLM could make quick work of, and that we could
Ah,
deploy into a use case really easily. But like there's
cool.
also the rules that you'd only learn by sitting down
Ex-
with all of the management staff of the site for 3 weeks in 14 different meetings that are each scheduled for an hour and a half, but none of them go less than 2.5 hours. Where in the
Oof.
15th meeting, someone happens to say, oh, well, yeah, you can't drive in that corner because that's the corner where this thing drains and all these people died once. So you got to go around that. And like,
And all these
unless
people
that's
died.
written down somewhere, the LLM won't learn it.
Yeah, that context. Yeah, it's interesting because there's a lot that's implicit, I think, in how people
Yep.
do things, and it may not be in a manual. Kind of just has to be learned for this kind of thing. Interesting. So has it
There's
changed? Oh, go
there's
ahead, Ilya.
yeah, there's a bigger meta point here on machine learning in general in robotics and our particular view on it. I was careful earlier to say that machine learning is this kind of sugar we sprinkle on top to really solve these corner use cases, because in a lot of our vehicles we actually want to safety rate our system. And again,
Oh,
safety rating is something where if you want to do an actual formal certification, it's not impossible with machine learning, but the
very
bar is
hard.
so much higher,
Yeah.
right, than very deterministic systems, which we can prove out 100% exactly what it will do in every scenario. And so the lower down the stack you get towards the underlying safety layer, the more and more rigid we become, and the more and more kind of rules driven we become. So
Yeah.
that machine learning side at the top can like maybe differentiate between a tree and a boulder, but it's never going to command the vehicles directly.
Yeah. So it has to pass
Because we
through.
need to deploy these things in real world. Yeah.
Wow. I love that. I can't believe I didn't think about talking about all of the safety certification stuff, but that makes a lot of sense, which is you guys can, because so these companies, they come and they try to build their own and they spend, you said like $50 million or some bonkers amount of money trying to build their autonomy stack, whereas you guys are making a business out of it. And then what you can do is you can invest as you need, or you can invest so that you actually safety certify things so they can just drop in
Exactly.
a safety certified system. That's really amazing.
Yep.
That's probably a huge competitive advantage and probably a very good moat, I would imagine, for you guys as a
Yep.
company as you're getting
Safety's really hard.
certifications.
And like safety is really hard. It's also hard to build a culture where people are smart about safety, where people are thinking about safety the right way. And essentially, because we use the same safety core on all of our machines, we're basically constantly getting learnings. We're constantly getting hours of testing to prove that the system actually works.
Mm. Yeah, so part of it is putting the case together.
Yep.
And because you have those deployed on systems and your systems have monitoring, and then you can log so that you can prove that this has happened for some amount of time so you can make these claims.
Yep.
That's nice. And so you can solve cases where they don't require the certification, but you can use those to bootstrap justification for additional safety certifications. That's clever. Hell yeah.
Yeah.
Yeah. And
What-
that's from a business side, that's also a big competitive moat for us, right?
That's what I was
Is
thinking.
over
Yeah.
time, because we really try to again keep that autonomy core the same and the same for the safety subsystem. So we'll build up hours of operation that are directly applicable across units faster because we deploy it across a much more varied fleet.
That's
And
super
of
cool.
course, as a roboticist, you can imagine the more varied use cases you
The better.
have,
Oh,
the much better quality actual proof you have of safety. It's not just the same test 100 times. It's 100 different tests.
that's super cool. Okay. What a thing. I really like that. Do you have safety certifications yet? Or like which ones do you have and what are you working towards?
Yeah, we're working. So there's two different threads we're working towards. One is internally, we want to certify to UL 4600, which is a fairly new standard.
Yeah, I'm not familiar with
it. The reason in particular we're targeting that one. Yeah, so it's kind of an evolution past the ISO 26262.
Oh, okay, I know that one. Okay.
Yep.
So what's nice about it is ISO 26262, if you go through the certification, at some point it assumes human takeover, whereas UL 4600 does not. And that's one but kind of key difference, And UL 4600 is more a umbrella standard of how to design a safe autonomous system without being prescriptive on like specifically follow this pattern. But it itself suggests things like IEC 61508 for sub-electrical systems and those kind of things, which build up proof to get to a UL 4600 certification standard. So again, it allows us to be more flexible. And if we want to go that direction, I can talk about how I'm really excited to turn safety certification into another CI/CD code problem.
I am. I would love to talk about that. No, I would love that. That sounds wonderful. I love safety certification stuff. I host spaces on X. I actually have one tonight. And you guys are welcome to come anytime. But they're like an hour and a half every week or something like this. We had one before Christmas sometime, and it was an hour and a half of talking about safety certifications. And after, it's like, I found my people. This is just wonderful. But okay, tell me. I would love to hear how you're thinking of it, like a continuous integration system, testing, this kind of thing.
Yeah. So having gone through this kind of process before, a lot of it is a very manual, like engineer sits down, writes a whole bunch of failure modes, get that reviewed, then they get testing, they get that reviewed. And then maybe a small piece of it is there's some requirement on code test coverage. And maybe that piece is part of the CI/CD. But I want to actually wrap the entire everything I've described as part of a CI/CD, so that every build we run for specifically our safety system, so we try to keep the scope very small and very simple.
Of course.
Not only does unit testing, but also auto-generates a lot of the, okay, to be in compliance with this part of UL 4600.
Oh, I love it.
We have this certification that refers to this thing. Here's in this particular vehicle, which is configured this way. So when we do a build for this vehicle, it has these characteristics, which we can pull in as their own proof for their use cases.
It's amazing.
So this vehicle goes at this speed, hence we need this speed of look ahead. Here's our proof of that look ahead. Here's our proof of the data. And to auto-generate as much of that as we possibly can, so that the end requirement, of course, you still need a human review.
Yep.
But
it's like a checklist.
lot of that is auto-built.
Yeah. That's awesome.
Rather than hand calculating.
Which is laborious for sure. That's awesome. So it would be like, effectively, it'd be like you have requirements. So you could take a standard, you could parse it and turn it into a bunch of requirements. The requirements might have parameters, and then you could use these to define specific tests that then you run that are part of your continuous integration and testing. Is that
exactly?
Oh,
exactly.
That sounds so cool.
And UL 4600, yeah, right. And UL 4600 in particular is written as this like giant spanning tree of a bunch of things. Like, to be compliant with this, you have to be compliant with this, and then you go to those. Like, to be compliant with that, you have to be compliant with this.
Yep.
So it's basically a big tree traversal problem of, to hit this, here's all my branches, and here's proofs for every one that then build on top of each other to get that one cert.
Oh, that's so cool.
That's what I want to build.
What a moat that will be.
That's what we're building. Right? But actually, I do want to open source as much of that.
I want that to be open source.
As I can.
Yeah.
Right. At least the learnings from it and the pitfalls we find and those kind of things. I do want to build that out, because I think for too long, safety has been this like, pay us X millions of dollars and we're a safety certification organization. We'll give you the check mark. Like, here's the golden check mark. I want to actually build the infrastructure to let other groups do that themselves. And of course, provide that service, we will as well. But just as basic autonomy, you should be able to build this yourself. But if you want a shortcut, you work with us, because we know how to do it. We have the proof points.
Yeah, actually, that could be that could even be like a side business or a side thing within your business, where it's like you basically have all this infrastructure to facilitate. So UL 4600. 4600. You could help robotics companies certify their software easily, because it's a pain that people have to go and learn all these safety certifications and all the details of it. And if it was like, here, hook up to your robot to our, like some sort of interface, and we're going to see if it passes in our environment, this kind of thing, that would be just amazing. That would be so cool. That would accelerate all of robotics, I would think. Like all different robotics companies.
And I think an additional detail is that while that's the umbrella standard we've picked, the reason we picked it is because it has a high enough barrier of proof and demonstration, that kind of stuff, that I believe at least, and
If
we're
you do
working
it, you
through
can do other
the
ones.
proof. Exactly. The same techniques we've used on UO4600, we can then deploy to whatever people need, because mining standards in South Africa are different than Australia, are different than the US. Instead of killing ourselves trying to comply with every one, we'll generate the products and then go to specialists on site and say, for your mine, you know how to certify. Here's all the data we have.
Yep.
What are we missing? What do you need that isn't part of this stack?
That will be really cool. Yeah, I really like that a lot. I think, making certifications, like, it's interesting because if we made them very algorithmic in a way, and you can parse them, so they're in PDFs or whatever, and you can parse them to make them like a tree of things that you have to go check, and then you have some document that shows all the requirements. That would just be so valuable. I had to, so I was the ROS boss for Humble for ROS 2.
Yep.
And built a tool that helped us with requirements. And so I did a pretty good investigation on the like requirements tools space to try to see like, okay, you have these requirements, they lead to these test cases and whatever, and how do you do it? And they were all horrible. So we ended up building our own.
They're all
naturally.
awful.
Yeah.
And super expensive.
And super
like,
expensive.
Ludicrously expensive.
And many of them had like free trials or something. So I would try them and they're just terrible. Like awful, everything awful and expensive.
Yeah.
But I think if you could make that good, that would be fantastic. That would be a big value to the whole robotics community, I would expect. I would love, and if you open source that, please let me know. I would love to see it too. Hell yeah.
Yeah, no, for sure. I mean, you know what? After this, send me that requirements if you have any notes on that. I'd love to see if we can integrate that. That'd be really cool.
Oh, hell yeah. Okay.
If there's anything public about it, throw it my way. I'll take a look.
The tool I ended up making was a bit simpler, and it was basically for, it's all open source, and it has aged a bit because I haven't had maintenance time for it, but we're still using it for every ROS 2 and Gazebo release.
Nice.
But yeah, I can send it to you. It's called Yet Another Test Case Manager was the dumb name that I gave it. But
I love it.
It was fun to build. And then, so we're coming to the end, but I would love to, we didn't talk about it at all about your podcast. So I'd love to talk a bit about that. Well, yeah, go ahead.
Right before we jump into that, can I do one quick diversion?
Yes, please.
Is there a chat feature in this? Can we send you, Audra, a link?
Yeah, it's in the bottom right.
I think we can.
Cool.
All right. So for our listeners, you'll have less fun than we do currently. But to describe it, I sent Audra a link to our live test tractor in Modesto, California. And I'm going to share my screen so you can see a video feed from it. And now what Audra's going to do is he's going to see
let me walk you through a little bit of what's going on. So live streaming here on the screen is a first-person view from our test tractor in Modesto, California. There is no one in this tractor, no one on site. The closest member of our team is about 100 miles away. The last time anyone in our team was physically near this tractor was probably Ilia and I back in like September. Audra, did that link work for you? You have it open?
I have a, it's like a Google Maps or something, and I clicked a location, so it looks like it's driving.
Did you, you clicked a location? Yep. There you go.
So
you just controlled our robot.
So the app that Audra just controlled was written by a buddy of mine who is a self-described 50th percentile engineer. He is just a front-end engineer at like a big, boring SaaS company. He knows nothing about controls. He knows nothing about safety engineering. He knows nothing about machine learning, mechatronics, any of that. Basically, in 20 hours, he took Mapbox's API to pull in satellite data of the field and took in our API to be able to see location of where the tractor is and issue commands to the tractor. And from that, Audra seems to have now sent us on yet another waypoint that the tractor is driving itself to.
That's super cool. I love that.
So it's doing a 3-point turn, and then it's because it will. So for listeners, Audra's clicking in a little yellow geofence, and we're seeing a live feed of the vehicle drive around. What the vehicle will always try to do is end up oriented from where it started to where it is. So usually they'll involve a 3-point turn. So right now it's kind of facing north. If Audro clicks somewhere south, we're going to turn around and then end up facing south.
I have now clicked
And
south.
this kind of easy to use interface, there you go. And this kind of easy to use interface where you just click it and tell it where to go is just kind of one example app, but the underlying REST API is what we actually use to control our vehicles. And this tractor could easily be a mining vehicle or a forestry vehicle, and it would behave completely differently, but Audro's clicking would be identical.
Just the other week,
on his end the same way.
we were co-hosting a happy hour at CES, and we were using the same app at like 9 p.m. Pacific time to issue commands to an AGV that our autonomy's on in Australia, made by a partner of ours, BIA5. So like the reason for this, and like the whole thought process here, if you want to automate a tractor, the special thing about automating a tractor is not the hardware that goes onto the tractor. It's not like the point-to-point navigation. It's like figuring out like the 5 screens and 4 buttons per screen that Farmer John needs to see and like interact with to make something valuable for Farmer John happen. And I don't know what Farmer John needs, because I don't know if Farmer John is in Ohio and grows wheat, or if it's really Father Juan in Spain growing whatever they grow in Spain. Either farmer probably needs a different UI. They probably need different behaviors to happen. We let our customers build that. We just solve the point-to-point nav part.
Huh. That's super cool. Did not know we were going to get a live demo. I love that.
Yeah, we did that demo, I think, 1,000 times last year. It was a real number.
Literally 980 something. Yeah.
Like, if you listener are on a call with me and it's during business hours, like, you will almost certainly end up getting a demo. And like, that's part of our secret evil plan to prove that our robots just work, is by like doing constant demos of like, this is not a big deal. This is not a big production. We're not even treating you all that special right now, Audro. We're just doing the thing we do every time.
That's great. It's great to not be treated special with the demo.
I know how you make. I know how to make you feel.
Yeah. Okay. Do you think so? It's very interesting to me. The web connects all of us. It's just like all our devices are running web stuff. Everything is making requests. I feel like in the robotics community, we've looked on REST APIs, which, I don't know, they have their get and put and post and whatever their requests. And we've looked at them and kind of gone, that will never work for robotics. And you guys are making these nice demos, and you have these simple REST API endpoints for querying. Tell me a bit about that. Like, is it the future of how we're going to interact with robots? As you think like a high-level REST API will manage things and you'll handle all the complexity on the robot side, but keep it simple for the user? Is that kind of how it will be? Or tell me about REST APIs and why them?
I think we when we were just getting started, we wanted something that every web developer and every language out there has an easy to use getting started guide on. So I think like Python or C or Rust or HTTP, Ruby, whatever
it is. Yeah.
And REST was this very simple to understand that you could even run from a command line if you wanted to, or run from a browser.
Just curl it. Yeah.
Right. Exactly. You can curl it. And it is a pulled interface in a lot of ways. So if, for example, we wanted to web stream, you notice the video I showed was using Formant as an actual web backend. We're big fans of Formant. We use them for this sort of stuff.
Okay.
REST is not the path. Yeah. So REST is not the path for streaming large amounts of data.
No, definitely not.
At all. Right. But the right tool for the right process. If you have a large fleet of vehicles, let's say 100, and you just need to be able to tell them vehicle A, go to this position, vehicle B, go to this position. It actually scales relatively well for that purpose. Without having to set up unique connections for each one, without having to manage WebRTC stuff. It's just spew out a bunch of commands from anywhere you are in the world, and they'll get to your robots. And because it's built on standard web technology, you get a lot of that security, you get a lot of that multi-threading, multi-user agent stuff is all well figured out. So we don't have to reinvent any of that stuff either.
And it can work both for this fun demo, which is a neat thing to do from a distance,
or for applications.
But it can also work if like everything is on the same site and there is no external internet connection. The same API can work for the vehicle in that use case.
Oh,
So
that's a big point.
Because the API is hosted locally. So the API is on the vehicle, right? And so the API could even be self-triggered. So something we don't have ready yet, but I mentioned that behavior tree. The long-term goal here is to be able to give our customers the ability to generate little subtrees and inject them back onto the robot for itself. So concrete example, if they're building their apple picking robot, they focus on
cool.
their arm to pick the apple, and then they onboard trigger an API function, move to the next
forward a
tree,
foot.
which they've or move to the next tree, which they've defined
Oh.
as move until you see a barrier under these conditions, whatever, like a little subtree of logic.
I like that. Yeah, so it can self-trigger. So you can basically have a system make its own calls from another call. So it can like cascade and this kind of thing. That seems
Yeah.
powerful to me. Very interesting. Seems a lot more complex, but seems like you could do some cool things. Or maybe you can get behavior that's more responsive with that kind of thing because it can trigger something right then. I bet, is that the big benefit that you get with it?
Exactly.
Ah, cool.
So it's local interactivity is definitely one of them. So again, and this isn't fully ready yet. So our current API, we can publish the API specs, they're online, but they won't mention this subtree behavior yet.
Yeah.
But one of our early clients, they just wanted a button that you could press to like press a button and the robot does X. And we kind of thought, we could write kind of a custom ROS interface. We could do all these things to get it to behave. But then we thought, we're already running an API. Let's just loop back the API call to itself.
Makes sense.
And that they just have their little button do a little programmatic REST API call, right? Which sounds funny, but it actually ended up being the most flexible approach.
Yeah. I would imagine it would be the most flexible approach. That seems great. So, and do you think that... do you think this is going to be a larger trend in robotics? I know, like a lot of companies, they end up wanting to put things into some sort of interface you can view from the web. And I guess this often means making endpoints for something. And I mean, sometimes they'll use WebSockets and things for streaming video or whatever it might be. But do you think that we're going to see a larger trend of robots doing more, being interacted with through a REST API or something like this? Like, is that something that you think will catch on?
I think, if I could jump in.
Yeah.
Sorry, Stefan. But, not necessarily REST in particular, but I think
just
the
web standards
in general has, right, like different web standards, whatever it is. If there's a new thing next month, Audro's special communication protocol, like, happy to write an interface layer to it because we don't care ultimately, right? Like none of our actual safety or behavior happens up there. It's just a translator. And I think we are moving in the direction where there's more connectivity for lower cost on more devices. Like there's a lot of this edge computing that's taken hold, a lot of cloud computing. So I think kind of covering our eyes and pretending that doesn't happen in robotics isn't the right way forwards.
I agree.
I think we have to accept that.
Definitely. And we might as well leverage everything that exists too.
Yeah.
Like there's just so much there where huge sums of money have been invested into improving these systems. And we might as well not reinvent that. So the web is great for a lot of things.
Absolutely.
Like that is my opinion on it. Hell yeah. What a cool thing. Thank you for sharing that.
Absolutely.
Yeah, I heard
Absolutely.
the podcast episode that I listened to that Nick shared you guys talked about the demoing, like instead of the kind of your culture where it's just like demo constantly. Therefore, it's not like you do a big demo once in a while and it breaks and this kind of thing. And I did not know that I would be seeing a demo now. So
I didn't know that
cool
that was
to
the
see you're still
podcast you
living
listened to, so that worked out.
Hell yeah.
CI/CD stands for continuous demo, by the way, just to be clear.
Oh, yeah. Instead of deployment. I love it. Continuous demo. Well, for you guys, it might be demos. Yeah. So what do you tell me about the podcast? I like at a high level, what is the Automate It podcast and what are you guys trying to achieve with it? Or I don't know. What kind of questions do you guys investigate? Maybe Stefan?
Of course, yeah. So every 1 to 12 weeks, we release a podcast on our podcast called Automate It. And basically Automate It is the podcast version of the fun robotics conversations you have with your friends at the end of a long day.
It does
We
seem
do
like
like two
that. Yeah.
sections of it, where the first is we each draw a random card to represent a technology and represent a business case, and then we have to spitball into an existence a robot that uses that technology in that business case, and we try to make them be stupid. Sometimes end up making them be good. Often make them stupid but representative of a real company, which is troubling every time. And then the second half, we'll talk about different challenges in robotics, like why indoor localization is hard, or why demoing often is good, or any number of these kind of normal things that happen when you're working on robots.
Mm-hmm. Let's see. Ilia, anything to add?
Yeah, I would just add that generally we do this talk after a beer or two, so it tends to be a little bit off the rails at the start. I think my favorite was we invented a bartending robot that was a bunch of arms on electrified rails that would fly around the bar to pour drinks or bring them to people.
Sounds great.
And yeah, very economically viable.
Definitely.
Yeah, it'd be a great business. But like in terms of why we started it, so a weird thing about our company is maybe there's, I'm sure there's more personalities in this, but maybe there's three archetypes of types of people starting robotics projects. There's like the optimistic producty business guy who thinks robots just work and like, let's figure out this, let's build a robot around this idea that I have.
It's an opportunity, basically.
Yeah, this is a great opportunity. There's the like young, dumb, and incredibly confident roboticist who maybe they just got out of CMU, maybe they just left some big robotics lab, and like that robotics lab, they did everything slightly wrong. And like as an individual roboticist, I one time made a project that looked kind of neat for a minute, so I'm gonna rebuild everything in robotics myself to solve every single problem, and it's gonna go great. And then there's this like kind of third archetype who either of those first two become after robots are jerks for a while. You know, like the type of roboticist you are when you once had dreams of solving general problems, and now you're just hoping like, God, I hope it turns on tomorrow and can kind of do something, and that like people let me keep on working on this. For Christ's sake, why won't it turn on? And that third group they tend to be our best customer base. Because the people who think that robotics is solved, the people who think that they alone can solve it, they're not going to let us solve point-to-point autonomy for them, because that will take them like a weekend probably. It's really the people who have been beaten up by robots, shoot up, spat out, who really want to make a robot work this time and create real value. That's who we sell the best to. So as a result, we made a podcast to kind of help people get to that stage of their robotics journey.
Oh, that's really cool. Yeah, so basically you're discussing all the things and you're letting people in on the process. And the idea is it helps people become educated in robotics sooner about how to make things, and that they can't do everything themselves, probably.
So like see the backstage pain and suffering. We were talking at CES just recently, and we were joking that we should have named it actually Robotics Anonymous as just a support group for here's all the pain we've faced.
Yeah. In the demo one, you guys talked about some of your past experiences, and they seemed super painful. With like spinning parts that were hot, and it was super cold out, and it was just crazy. But yeah, I feel the thing that is interesting to me is I was definitely stage 2 or whatever of what you were doing while I was in grad school. Like I tried to build Ross at some point, and then by the time I got
you were going to do it the right way.
Yeah, I know. And then I got to I needed something like RViz and something like Ross 2 bag, and it was like, I guess I'll just use it and this kind of thing. But now, I mean, it's been interesting because I've been mostly on the software side. And so I'm trying to do some robotics side projects occasionally and like buy a bunch of stuff from SparkFun and hook it up to Ross too and things like this. And it's a lot of work. And the thing that is really becoming clear to me is to do a good job at robotics and to like actually build value, you need a lot of people, which is interesting because there's so many things to do where you need the CEO who goes and figures out the market and knows, and you need a domain expert and you need the technical guy and you need all the manufacturing knowledge, and there's a million things.
Yeah. And like, I think I would argue that like for robotics to be the space we all want it to be, you need to build a product, you need to build a company, you need to build an organization where you only need to be good at one part of it.
Definitely.
Like
That's what
maybe
you guys
you're
are
doing the hardware, maybe you're doing the retrofit, maybe you're getting really smart about what farmers in Ohio need as a UI, UX, and as robotics behaviors, and you're using somebody like us to do the driving and someone else to retrofit the vehicles. And like, if you're willing to do just that, it's still going to turn out to be incredibly hard, because it turns out like, as much as like we all might make fun of DocuSign 5.0, it's hard to build DocuSign 5.0 or How to Not for Cats. Like those are hard businesses to build in their own right. And like by focusing just on like the specific part of the value that you have a unique insight to, we can all go make robots.
I like that a lot. Ilia, anything to add?
I'd say, you know, from the content creator perspective, so Nicole, our kind of marketing guru, suggested this to Stefan and I, and to start a podcast. And at first, kind of both Stefan and I were like,
pass.
a little leery, you know, like, I got enough, like,
You're doing a lot.
kids, like, I should probably spend some time with them this week at some point. Yeah. But realistically, it ended up being super fun for us, and I think that kind of unstructured part helps get us in the mood and talk about random, crazy Robotics Anonymous topics. And secondly, I think it ended up being hilariously effective as a marketing and outreach tool. It's not like we don't have 1,000. We don't even have 1,000 listeners. Like, we don't have a lot. Like it's a very small listener group.
It's a niche podcast.
But the funny thing is it's very niche, right? But the funny thing is any conference we'll go to, invariably at least one, if not multiple people, will come up and be like, "Oh yeah, you like I've listened to your podcast." Like, specifically the people we want to work with.
Yep.
Totally.
Yep. And they'll be kind of specifically like, yeah, maybe you can help us. What we're doing is really hard. It seems like it's been hard for you before too, and maybe you can do some things better than we can. Like, yeah, we'd love to. We'd love to commiserate with you on robots and help automate it.
Yes. Oh, that's so funny. Yeah. I have that too, where it's a small fan base, but they are awesome. And I get recognized just a handful of times at every conference. They're like, "Oh, I love the pod, whatever." Or you should talk to this person. It's just, I don't know. It's such a cool, wonderful thing. I feel like talking to a small audience that really likes the content that you make is really wonderful. Like there's something just glorious in it. Like very, very enjoyable.
I think it goes back to a basic like Paul Grahamism of like make 100 people love, or make 10 people love you as opposed to 1,000 people like you.
Yeah, it's a good way to look at it. Paul Grahamism. Yeah.
Yeah.
Hell yeah. Well, that's super cool. I love the reason for doing the podcast. And it's funny that it can bring you people to commiserate with and help kind of educate, to move people towards this. Like robots can be really cool and they can solve a lot of things, but they're really hard. And I don't know. Okay. So you got to approach it that way. Like they're super hard.
Yep.
Let's see. So where do people find your podcast? Is it on all of the different ones?
So we're on all the major outlets, Spotify, Apple Podcasts, whatever. Just call to automate it. And there's a nice cartoonish image of Ilia and I both donning facial hair and looking incredibly dapper.
Nice. Yeah, I think it's funny because I've listened to a couple of your episodes, and they're the beginning is very much complimenting each other's hair. For this kind of, it's like, "Oh, your hair is looking lovely today, a little poofy."
For anyone viewing this, that just makes obvious sense. And for the people who are just listening, imagine the most incredibly good-looking people ever, and that's exactly what we look like, especially in the hair department.
Yep. And then do not go onto the YouTube.
Stefan starts the episodes critiquing my Stefan
you
usually
sound like
starts by critiquing whatever I'm wearing that day, which is
Really?
always a good start to our podcast episode.
How
It's
funny.
like, same shirt I see, huh?
I mean, I wear a black
That-
shirt in every episode, so. But
This sounds a lot like my wife, who tells me I look the best with a mask on.
how funny. Not gonna touch that one. So let's see. We're coming to the end of the time. I can talk a little bit more. I don't know if you guys have a hard cutoff or anything.
No,
But we're at the
I
end
don't
of.
think so.
Okay. I wanted to see what you guys have for advice for
Yeah.
people wanting to get into robotics. Like say it's someone who's in the middle of their university or something. What should they know, or what would save them time? Maybe start with Stefan.
Yeah, so maybe I'll answer this more for people who are interested in robotics products, and Ilia can talk about it more from an engineering perspective.
Love it.
I think when you have not built a robot yourself and you're looking in, a very common intellectual fallacy or flaw that you fall into is that you see things that have been built before and you assume that's no big deal. And I'll grab an arm from a Toyota factory, I'll grab a Waymo car, and then I'll have a car that can drive around and put mail in mailboxes, and it's going to be great. The weirdest and shittiest and hardest thing about robotics from a product and a business and investing perspective is that, unlike the world of like SaaS apps where any feature is purchasable as a microservice, in robotics, basically every feature that you see, every supporting piece of tooling, every supporting piece of infrastructure, almost everything that you see has to be reinvented from scratch. Like, with the exception of like some of the stuff in ROS, that is in general mostly a lot harder to set up than any piece of tooling that you would get for starting an e-commerce site. So like
Definitely.
a good robotics business, a good robotics product is a matter of like, what is a thing that is super expensive for humans to do? Like, just there's an incredible labor shortage around it, and is kind of drop dead simple for a robot to do because it needs kind of the same thing to be done over and over again. And like, start with that, and don't just start by combining robots you've seen on in TechCrunch.
Love it. Hell yeah. Ilia, what do you think?
Yeah. So on my end, my thoughts are kind of summarized. So I really love XKCD. I'm sure a lot of people listening have
Those
heard
comics.
of that webcomic.
Yeah, they're great.
There's a particular one that's like, right. There's one that's like, oh, we built this robot that like shoots lightning and is also an air balloon and whatever. And somebody asks like, what is that for? And they say, search and rescue. Like, that's like the default answer for robot projects. It's like, oh, search and rescue. So I think the trap that engineers fall into is kind of solutionism or robots for robots' sake. And I love to do that for my own life. Like, I build lots of fun trinkets just for fun for myself, but that is not a business. And so as an engineer, really try to step back and to give it the question of, is this the most effective way I can solve this problem? Is robots really the answer here? If not, you're going to bang your head against that problem, regardless of how good your tech is. You're just not going to solve it. I'll give a really quick, concrete example. There's a mining project which they're interested in building autonomy and stuff like that. But in the short term, they're saying their immediate term goal is just to reduce the amount of idling that their fleet does. Because across their fleet, when their drivers just idle the engine, they waste like multiple millions of dollars a year of diesel.
$8 million
just to keep
a year of diesel.
Bonkers.
Wasted because
Right,
the operators won't turn the engine off. Because if the engine's
Right.
turned off, it looks like they're not working.
Huh.
Right. Or because they want to keep the AC on, right?
Mhm.
And as an engineer, you know, my thing is like, oh, well, we can automate their vehicles and we can do all this thing. We can put in all these monitoring systems. And then the answer is like, or you could just have a 10-cent circuit that if you're idling for longer than X, automatically turns off your engine. And like that 50 cents or that $2 solution is worth $8 million, right? Not particularly interesting. It's a 5-5 timer and a switch,
Mhm.
but worth $8 million off the bat. So really, when you're being an engineer, really try to think like, do you actually need robots here? And if the answer is no, and you want to be a roboticist, look for a different idea. You're not going to tech your way through this problem.
Mm-hmm.
Yeah.
And, go ahead, Stefan.
I was going to say, so an interesting thing, when I was working at my self-driving trucking company, we got to the point where being better at writing software to manage a trucking fleet would make us more profit than solving general autonomy. So like we were autonomous like 95% of the time we were on highways, teleoperated for the last 5%. And like being more clever about how we route trucks, being more clever about like automatically telling more brokers that trucks are available for a load, that type of stuff would add more cents per mile of profit than like $10 billion AGI solution type of thing. And that realization made my board member think, or maybe I should scratch that, made senior financial people connected to us think, why don't you guys just let go of the robotics team? Just focus on being a software focused trucking company. And like when robot trucks get solved, you buy whoever makes the best ones. Which I think is going to happen to a lot of the vertical folks, where it's going to become like, running a day-to-day business in this heavy industry, these companies suck a lot. Just by bringing in like standard Silicon Valley practices of how to manage resources would make you more efficient than most of the world's biggest industrial players. Yeah.
Yeah. That's bonkers. What a thing. That was probably a hard time, I would imagine. With that suggestion.
Yeah, that was a like, I can't tell a lot of people on the team about this or morale would drop pretty suddenly.
Plummet. Yeah.
Yeah.
What a thing. How much longer, what actually, I know we're late in the thing, but what happened to that company and where are they at now?
Starsky ran out of money. We failed pretty in like late 2019, right before 2020. Around that, by that time, we, to my knowledge, were the most commercially successful L4 trucking company. We were doing about $7 million in annualized revenue run rate in freight that we were hauling, mostly with regular trucks, but our customers thought we were hauling freight with like unmanned self-driving trucks. We did the world's first ever driver out autonomous run on a live highway. So we drove a truck for 7 miles, like in regular traffic with no person in it. And we went to VCs and we're like, hey, look, the tech works. Like here's our safety testing plan that will allow us in about 12 months to be having 5 trucks driving about full time with no person in it. The business more or less works. Like, here are the things that we need to do to make it be outright profitable and an interesting and like very cookie cutter running a trucking company types of things that we need to do. We've proven all the stuff. Like, let's go, give us $50 million.
Yeah, we did the hard part.
Super profitable. And VCs looked at us and were like, wow, so you're working really hard. Running a trucking company is hard. Robots are hard. And you're saying that with another $50 million, maybe it can be a trucking company with 50% margins. That kind of sucks. I would way rather give $50 million to DocuSign 5.0, where for $50 million, they'll create $40 million of revenue, but they'll have 90% margins on it. And anyone in San Francisco can run that company. Like, you don't need some special weird unicorn. Like, anyone in the world can run a unicorn SaaS company.
Man. That's crazy.
This autonomy thing isn't a great business, is it?
Oh, what a thing.
Yeah.
Okay. And then, so after that, then you effectively picked yourself up and then have started Polymath with this and used a lot of the lessons and like interesting. I see.
So like COVID happened. I went and hung out with a bunch of SaaS companies. I had an interesting experience where while I was hanging out with SaaS companies, I took a deep look at like the NetSuite ecosystem, if you're familiar with it.
Is that like Microsoft? The .NET or what's NetSuite? I don't know.
So NetSuite is this big crappy piece of enterprise software to kind of do accounting set up in a super special way. So like if you've worked at a company with more than 500 people, they probably use NetSuite or something like it. Like, think of it like QuickBooks, but like a couple $1 million and then a couple $1 million to implement it a super special way, because like Coke likes to do its accounting slightly different than Pepsi does, who likes to do it slightly different than, I don't know, Snapple or whatever.
Okay.
And when I looked at that ecosystem, I saw software that didn't just work, right? There was software that like, it wasn't like Gmail where you swipe a credit card and you have and you have an email account. It wasn't like Uber where you download an app, hit a button, and a car shows up. It was
Mhm.
software where you buy it, you
Business to
spend a bunch of
business.
time integrating it, not even just
Configuring.
business to business, but you spend a
Ah,
bunch of time configuring it to work just for you. And then it is one of the most valuable pieces of software in your entire stack.
whoa.
And I don't think robotics is ready to be Gmail yet. And I don't
Yep.
think robotics is ready to be Uber yet. But I think robotics is ready to be something that you buy, configure, and then is a key part of how your business operates.
Cool.
And that's why we're building
like
Polymath the way we are.
I love it. Almost like a, I don't know, Zapier or something, like some automation service or
Like
something.
Zapier without a nice UI. With Zapier, but you have to hire consultants to set it up.
Yeah. Cool.
Like
Yeah, I
Zapier's
think
pitch was probably like, we make it so you can do Oracle type integrations without a team of consultants, was probably their seed pitch.
uh-huh. Yeah. What a thing.
Yeah.
Okay. Let's see. So last one more thing I wanted to ask. So we had advice. You guys both gave your advice. Oh, Ilya, I wanted to ask because you mentioned side projects, you build your own trinkets for these kinds of things. I wanted to see what you think of side projects. Like, I think they're super important as a way of kind of growing your skills and staying relevant. But I want to see what your perspective is on them, and from a CTO perspective too.
Yeah. Yeah, no, for sure. Two things. One is my side projects keep me sane, because especially as you get into the into the more CTO roles, like I would love for most of my day to be coding, but like maybe 10% of it is realistically, and 90% is everything else. So doing the side projects keeps me happy.
Mhm.
But the other funny thing is that my side projects end up being aligned with Polymath some of the time, which is kind of interesting. So early on, we didn't really have a good way to emergency stop our vehicles remotely. So as the demo we gave, we have this completely remote vehicle. So like none of the line of sight e-stops will work for us, right?
Mhm.
And Fort's wireless over network stuff wasn't ready, and nobody else is providing anything of real value. So because I had built up some stuff in like Arduino land, basically, I was able to quickly throw together a prototype emergency stop that ended up being relatively robust.
Nice.
And those sort of things, I think TLDR is that side projects are critical, especially, I'd say there's almost like a bathtub curve. When you're junior, they let you iterate quickly. And when you're very senior, they let you keep your sanity because seniority tends to correlate with meetings. Not always, but in a lot of ways. So they let you like just quickly prototype something and test it out. And I find the risk for, I would say not as much in robotics companies, but for software companies in general, is over time as they become larger, there's this growing divide between people making decisions and people writing code. And if the people making decisions don't make a habit of writing code and being connected to the system, and like basically being a chaos monkey is another thing that I do quite often that I highly recommend.
I don't know what it
We'll
means,
put out
but
an
it sounds
API and I'll just
wonderful.
like write like the worst possible code.
Yeah.
Well, yeah, it's just like I'll write the worst possible code to talk to our API and break a whole bunch of stuff by accident. But by doing that, we'll
Oh,
figure out like, oh, like we didn't handle this exception,
exceptions.
or like
Yeah.
a dumb user like me would have thought it works this way, but it works that way, and like all of this stuff, and all of that all flows into keeping your sanity and having a good business.
Mm-hmm. Hell yeah. Yeah. I think it's an interesting thing. I feel like I've been doing side projects really regularly for a few years now. Like every evening I'm working on a side project,
Oh,
which I
cool.
absolutely love. It's like some of my favorite time each day. Um, so one of the things with that is I feel like you learn through your own pain how to make good architectural decisions. And I feel like that's a very hard thing unless you're going end to end in something you're building.
Yeah.
And it's like if I just focus on the one specific narrow thing that I'm working on in work, I don't understand the end-to-end process. But when I'm working on that one specific thing, it's easier to make better decisions if I understand the larger context through doing the whole process through side projects. That's been one of my thoughts on it recently. But
Yeah, it makes a lot of sense.
hell yeah. All right. So last questions. What are you guys excited about in robotics? Like, what are the things you're looking forward to? Ilia, let's start with you.
I'll come back to my experience, at least with Amazon, where the Astro program, I think, and you know, for your listeners, if they haven't seen, so Amazon has a home robot called Astro. You can find it online. Theoretically, you can buy it. I don't know. I don't make their business decisions, but you can actually play with this thing. It works reasonably well. We have one at the office just for fun. But them and Samsung and Sony and basically everybody and their dog has made these kind of human interactive robots. But the little piece that they're missing is the question, the very small question of what the hell does it do, which nobody has answered yet. And the killer app for robots in the home seems to have been vacuuming from like the 1990s till today. And nobody's come up with a better idea. And I'm still waiting for what is the next killer app for robotics in the home. Putting away dishes or laundry, like everybody, that's the first thing everybody jumps towards. But manipulation is very expensive and complicated. And even if ML magic fixes it, like just the actuators are very expensive.
That's true.
Like nobody's going to spend even $5,000 on this, right? And $5,000 for a manipulator is ridiculously cheap, right? For a good one that moves around and stuff. Anyway, so I think we're still missing the killer app in the home for robots. And I'm excited to see what that ends up being. Maybe it's kind of an embodiment of these assistance, machine learning based approaches of kind of just shout in your room like, hey, find me a path to this theater. And this screen kind of magically comes over and talks to you and tells you what to do. I don't know. If I knew, maybe we'd do that company. But for now, we're in industrial space and kind of a different business.
This whole thing sounded like what we did at the beginning of our podcast, where we'll start coming up with these things and be like, yeah, but wait, I can already ask that question anywhere in my house and it gets answered for me. And the screen that pops up is my cell phone. And like, it just kind of happens already. So why do I need a screen on an arm in each room of my house? I'd say like what I'm most excited about. So for better or worse, the self-driving car industry threw a lot of money and interest into robotics. I think like more than other spaces. I know there's a lot of quadcopter people, but from my own perspective, it seemed like way more people got way more excited about self-driving cars than quadcopters. And now there's a lot of people who have worked in and around robotics. And like some of those people have been siphoned off to LLM wrappers for XYZ. And like some of those will become real businesses or not. And there's like there's a similar flavor of self-driving car hype that's happening in humanoid robotics right now. And my hunch is it will go roughly the same as it went with robotaxis, which you could decide how much sarcasm you want to read into. But I think we now have a critical mass of people who care about robots, who are hooked on these sorts of problems in such a way where Dropbox 5.0 is no longer an appealing job. And that like now, like they need to build robots for something. And many of those people will work on nonsense, like the robots for robots' sake. But I think we're going to have more real robotics companies doing valuable and interesting things founded in the next 5 years than we had the last 100 years. And I think like right now, probably the most successful robotics company of all time outside of defense and mining is probably iRobot. And I think you'll have 5 to 10 companies as successful as iRobot in the next 5 years. And maybe even like 50. And that's going to be fucking cool.
Hell yeah. That's awesome. I think you're probably right with that. And I think that is such an exciting thing. And that matches my observation too, that there's a bunch of people that are kind of hooked on this and they want to be using it for
because man, boring SaaS just is like not something like I desperately did not want to start another robotics company. Like I was so wanting to do something simple that like I was even working on like an e-commerce for planning funerals idea for like 6 months. That seems more cheerful than like go be miserable in the mud with robots. And the
Oh,
thing is,
man.
I just can't work on anything else now. And I think
That's so funny.
like a lot of people feel the same as me. So maybe right now, some of them are doing, open AI for asking your plumber questions. And like, there's money in that right now. But there's a lot of people at those companies thinking, how do I get back to robotics? Where do I find a robotics application that is fundable and buildable and valuable? And I can't wait for that to start bearing fruit.
Me too. Hell yeah. I love that answer. Okay. Hell yeah. Well, thank you both. It's been so much fun having you on the podcast.
Thanks so much, Aljo.
Oh, yeah. All right. Bye, everyone.
It was a pleasure hanging out. Thanks so much for joining us.
You made it. I should be quiet just in case you are sleeping peacefully. In any case, I hope you enjoyed the interview. What did you think? Is Polymath Robotics onto something? Would you use their service? Did you like the demo? I'd love to hear what you think in the comments or on X. Also, I host a weekly space on X on Thursday evenings, US time, where we talk about all things robotics, including this interview. Feel free to come and chat. Okay, that's all. Happy building.